Today we're going to pick back up and go a little bit deeper into what's called an arithmetic sequence. This is section 9.2. Alright, so remember what an arithmetic sequence was. We said that there's a constant difference to go from one number to the next. Like if we had a list 2, 5, 8, 11, you can see that we're going up by 3 each time, right? So the actual definition of an arithmetic sequence is a sequence whose difference between consecutive terms is constant. And we actually call this difference, it's called the common difference. And the way that you figure out the common difference is just like we did over here. We said, well, 5 minus 2 is 3. 11 minus 8 is 3. Right? So what you do is you do the next term in the sequence minus the previous term. All right, however you want to think about it. All right, so first thing we'll do is let's find the common difference and I have 4 examples here. So what if we had a sub n is equal to 4n plus 3? Well, the first term, second, third, right? Let's see here. The first term would be 4 plus 3 is 7. Then 8 plus 3 is 11. Then 12 plus 3 is 15. Looks like the common difference here would be 4. What about if we had a sub n is equal to 7 minus 5n? Well, the first term would be 7 minus 5. Second term would be 7 minus 10. Then 7 minus 15, which is 7 minus 15 is negative 8. So the common difference, negative 3 minus 2, is negative 5. What about a sub n is equal to 1/4 times n plus 3? So the first term would be 4 over 4. Second term would be 5 over 4. Then we would have the third term would be 6 over 4. If you were to subtract these two or subtract these two, you would see that the common difference is 1/4, going up by 1/4 each time. And the last one, what if we had a sub n is equal to n squared? First term would be 1, then we would have 2 squared is 4, 3 squared is 9. There is no common difference. So we'll just say does not exist, DNE. All right, so let's get into formulas with this. We'll say that the nth term of an arithmetic sequence has the form a sub n is equal to dn plus c. where D is our common difference. Which we just talked about how to find. And C is going to be the first term minus that common difference. All right, so D would be our common difference. It's this. And then C usually goes right there. All right, so let's get started. Find a formula for the nth term of the arithmetic sequence whose common looks like my computer froze a little bit. All right, so sorry about that. Let's pick up where we left off here. All right, so we're going to find a formula for the nth term of the arithmetic sequence whose common difference is 3 and the first term is 2. Okay. So let's see here, the common difference. So our formula is a sub n is equal to dn plus c, and the common difference is 3. Now to figure out what c is, we're going to take our first term and subtract the common difference. All right, so we want the nth term, and there we go, right there. What about if I asked you to write the first several terms of the arithmetic sequence whose fourth term is 20 and 13th term is 65. All right, so let's see here. In order to figure this out, we have to go from 20 to 65 over the course of 9 terms, right? So this would give us 9 terms. We have to go from 20 to 65, which is a difference of 45. So what we could do is 45 divided by 9 tells you how much you have to change it each time, right? So 45 over 9 gives us 5, which is our common difference. And let's see. it looks like if we know that, I mean, the fourth term would be 5 times 4 is 20. The 13th term would be 5 times 13, which is 65. So it looks like we already figured that out. All right. What we did is we found out what is the difference between these two numbers, and then how many opportunities do we have to make up that difference. This is the difference, and this is the number of terms. Let's talk about how to write a recursive formula. Remember what a recursive formula means. This just means the next term in a sequence is based on the previous terms. Like Fibonacci's sequence, right? So what we could do is we can make a little formula here. Remember that what we've been using was the nth term in a sequence is the common difference times n plus c. And we said that c was equal to the first term minus d, right? So let's substitute that in. What we could do is we could rearrange this. So it looks something like that. We could factor out a d, and that's the formula we have. All right, which is telling us the nth term based on the first and the term before. This will be the last example. Let's find the seventh term of the arithmetic sequence whose first two terms are 2 and 9. Now, we know that the first term is 2, right? If those are the first two terms, it's an arithmetic sequence, so we do have d. D would be the common difference between 9 minus 2, so we get that d is equal to 7. And really, we could use that to come up with our formula, right? So we know that a sub n would equal the first term plus the common difference times n minus 1. That's our formula. So we want to know what the seventh term is. So a sub 7 is equal to 2 plus 7 times 7 minus 1. So a sub 7 is equal to 2 plus 7 times 6, or the seventh term is equal to 44. All right, so that's using the recursive formula. Another way that we could do this is to use our basic formula where a sub n is equal to dn plus c. And a sub n would equal the common difference times the number plus c. And remember what c was. C was just the first term minus that common difference. So 2 minus 7 would be, let's see, yep, so we want to get the 7th term here. So 7 times 7 is 49. 49 minus 5 is 44. So we can get it using our recursive formula, or we can get it using our arithmetic formula. Okay. And just to note too, you might even see, like in the book, sometimes they, don't write the formula quite like this. There's all different variations. So in the book, you might see like a sub n is equal to a sub n plus like n minus 1 times d. I mean, it doesn't matter how you write it, but I showed you where this came from using the arithmetic formula. So for homework, what I would like you to do is please try on page 635. I'd like you to do numbers 3, 5, 13, 15, 25, 29, 39, and 41. All right, good luck. Have a nice day.